All right, so this is a key on the worksheet on graphing inverse functions. And so in this problem, you have this function, and you want to graph its inverse. First of all, notice that this function is a one-to-one function. So when you use the horizontal line test, notice it'll intersect the graph only once everywhere. So it's a one-to-one function, meaning that it's going to have an inverse. So you want to graph it. Now to graph the inverse, when a graph is given, to graph the inverse, always make sure you graph the line y equals x, because inverse functions are symmetrical about the line y equals x. So always do that. It helps you to make sure that the graph you end up with is the actual graph of the inverse. So remember though what y equals x means, just to remind you, notice y equals x is a linear equation, right? So it's a line, and all you need are 2 points, and y equals x means x and y are identical, right? That's what that means. Y is the same as x. So if x is 0, y is 0. If x is 1, y is 1. If x is negative 2, y is negative 2, and so on. That's what that means. So notice that when you graph the line y equals x, the line y equals x is only in quadrants 1 and 4. And in fact, it divides quadrant 1 in half, and it divides quadrant 4 in half. So let's go ahead and I'm just going to plot a few points here. 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. So that way I can draw as best a line y equals x as possible. All right, and so, I'm going to use a dotted line to represent the line y equals x, just like this. All right, dotted line to represent the line y equals x. And okay, so that's going to be y equals x right here. Okay, now remember when you have a graph of a function, to graph its inverse, remember inverse functions, the coordinates are interchanged. Remember how when finding the inverse of a function, we would let y equals x, x equal y, and then solve for y. So we interchange the coordinates. So that's what you do here. So what I mean is this. Right here, this point right here, I'm giving you some points on this. This point right here is negative 6, 3. Negative 6, 3. What that means is this. The x becomes the y becomes the x. That's what that says. Okay? So the x becomes the y becomes the x. So in other words, you interchange those coordinates. So negative 6, 3 becomes 3, negative 6 on the inverse. So 3, negative 6 on the inverse is about here. Okay? Then in this point here, which is negative 1, 2, the on the inverse, it becomes 2, negative 1. So 2, negative 1 is right here. Okay? And this point here, which is 2, 1, becomes the point 1, 2. Well, 1, 2 is right here. That's 1, 2. All right, so remember, if my graph is on, see how this function, this part of the graph is above the line y equals x? So when I do its inverse, it's going to be below it. This part of the graph is below the line y equals x. When I graph its inverse, it's going to be above it. Okay? So it's symmetrical about the line y equals x. So this point here, which is 3, 0, I'm going to go ahead and just mark 3, 0 here. 3, 0, it becomes the point 0, 3. So 0, 3 is 0, 3 is right here, right? Right here. That's 0, 3. Okay, so now I'm going to use a different color to graph the inverse. So notice that this has an arrow, this is an end point. So always notice these things. That's an arrow here, this is end point. So this end point, when I reflected it about the line y equals x, becomes this point here. All right, so do the best you can with graphing this. So it looks something like this. And one other thing I got to remind you, wherever, you see how this function intersects the line y equals x here, the inverse will do the same thing. So the inverse, so these two functions that are inverses of each other are going to intersect on the line y equals x at the same place. Okay, so since this function intersects the line here, the inverse will do the same. All right, so let's go ahead and do this just like this. Do the best you can. Notice I'm being very careful, and I don't have a pencil, so I won't be able to erase. And it looks something like this. Okay, now be careful because some students, what they'll do is they'll want to go ahead and draw the arrow coming this way. So I'm going to go ahead and use a pencil just to show you it doesn't do that. So they want to do something like this. Okay, that's not true. Okay, that's not true. First of all, it would no longer be a function because it fails the vertical line test. So if this is a function, the inverse has to be a function. All right, so be careful. Always think about the knowledge that you have. So if you do this, it's no longer a function. So you know it can't come this way because it fails the vertical line test. All right, so that's it. All right, so there's number one. Okay, number two. And by the way, if you want to go ahead and label those points, you can. So this, you remember how we said negative 6, 3 became 3, negative 6? So here's 3, negative 6. Negative 1, 2 became 2, negative 1. So that's right here, right? The point here, which is 2, 1, became the point 1, 2, right here. And this point here, which is 3, 0, became the point 0, 3, which is right here. Okay? All right. Now, number two. So number two, we have this function. Notice that there are no arrows, so those are endpoints. So keep that in mind. Those are endpoints. That's where the graph ends. That's why it's called an endpoint. All right, so let's go ahead and graph the line y equals x the same way we did in the previous problem. So 0, 0. And by the way, you see 1, 1. Negative 1, 1 is that point right here, right? So, so y equals x is going to touch this graph right here. Okay, so 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2, and so on. All right, so let's go ahead and graph our line y equals x. All right, so do the best you can. Do the best you can. You do have an eraser, so you erase it. Just make sure it's going through the first and second quadrant. Notice it divides the first quadrant to 2 equal parts. Those are both 45-degree angles right here. This is 45, and then the same thing here. This is 45, 45. Okay? All right. Now, let's go ahead and graph the inverse. So this is my function f. I'm just going to go ahead and call it f right here. If that's my function f, I want to graph the inverse. Remember, those are segments, so that's easy. This one was a little curved. This one had a curve to it. So sometimes when graphing curves, it's a little bit harder to make it look symmetrical. But this should not be difficult because those are segments. So look at this segment and then look at this segment. You look at those endpoints. So this point here, which is negative 4, negative 3, right? All right, on the inverse, that's negative 4, negative 3. On the inverse becomes negative 3, negative 4. So negative 3, negative 4 is right here, okay? This segment here, the endpoint of that segment that we're looking at, that endpoint is negative 1, negative 1. The inverse, on the inverse, it's negative 1, negative 1. So hence it stays on the line y equals x. So remember, wherever the function, if I call this f of x, then this would be f inverse of x. So notice wherever f of x crossed the line y equals x, the inverse does the same thing. So notice that f of x touched the line y equals x here. The inverse will do the same thing. All right, and then finally this long segment right here, let's go ahead and look at this endpoint. This endpoint is 3, 7. So the inverse, it's going to be 7, 3. So 7, 3 is right here. And so just connect the segments, the points. So here is So this segment here, now remember, see how this segment is above the line y equals x? Want to graph the inverse, can be below it and symmetrical to that line. Looks like this. Okay, so there's that blue one right here. And then see how this line is above the line y equals x? When I do the invert, when I graph the inverse, it will be below it. And just connect this point with that point, and that should be it. Okay, so notice, I'll always make sure that this graph right here is symmetrical about the line y equals x, as it's supposed to be. So f of x and f inverse of x have to be symmetrical about this line, and notice they are. See this? Okay. All right, and that's it. All right, now remember, those are segments, so don't keep drawing this because this part here is not part of the graph. There should be nothing else here. These are endpoints, so make sure you stop at an endpoint. All right, so that is the key to graphing inverse functions using the fact that inverse functions are symmetrical about the line y equals x, and using the fact that if a point is xy is on the function, then on its inverse it will be yx. So you interchange the coordinates. So negative 6, 3 becomes 3, negative 6, and so on. All right, so fairly simple, not a difficult concept. All right, so that is the key for this particular worksheet.